Hello, everybody. We are back with another visual pattern challenge. And today's challenge is kind of funny looking. These are trapezoid tables, and these are little people sitting around them. We're seeing this from above, and we can see their little noses hanging over the edge of the table. So your challenge here's step one, here's step two, step three, we've even got step four. Your challenge is to predict how many people could fit around tables arranged like this if there were 5 of those tables in a row. If you can do that, can you figure out how many would fit around 43 tables? And could you come up with an equation to express the number of people that could sit around any number of tables at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. So this is an interesting challenge because I think it really applies to the real world. You might actually be in a situation someday where you are arranging trapezoid tables and you've got to figure out how many spaces there are for people to sit. This kind of problem might actually tell us whether it's more efficient to line your tables up like this or whether you can fit more people around if you just leave them separately without connecting. So kind of a cool pattern to look at. Let's see if we can just get a visual sense of what's going on here so that we can predict step 5. So it looks like if you have a single trapezoid table, you can fit 5 people around it. That makes sense, 2 on the long side and then 1 each on each of the other sides. And then something interesting happens when you put the tables together, right? That person, you can't sit in between the tables because they're right up against each other. So that person goes away. It's like you subtracted 1 and then you add 4 more. And then if you add another one, look, only 3 people can sit around this table now. So it's like you've subtracted another one, but then you've added 4 more. And then here, so same kind of thing is going on. So the middle tables can only seat 3, the outer tables can seat 4. So I guess if we're going to add another trapezoid table, that's a terrible trapezoid, but this person's going to go away. And then on the long side, we've got 2, and then 1 each on the other sides. So how many would that be? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I think there are going to be 17 people in step number 5 when we have 5 tables. So let's take a moment to analyze these numbers. It's something odd going on. We're subtracting and we're adding. I think it's going to be a linear pattern, but let's make sure. I'm going to make a chart here, and we're going to have the number of tables and the number of people that can sit around them. So when it's 1 table, you get 5 people. When it's 2 tables, it's 4 and 4, that's 8. When it's 3 tables, you get 4 and 4, 8, 9, 10, 11. And when it's 4 tables, you get 4 and 4, that's 8, 9, 10, 11, 12, 13, 14. And we said 5 tables would be 17. Okay. Now let's find the difference between each step. 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3, 17 minus 14 is 3. Aha. So we've got a constant difference, and that means this is a linear equation. And we're going to use our formula for a line to model it. So y equals mx plus b. The m, the slope, is the rate of change here between each step. So it's going to be y equals 3x. And the plus b is going to be whatever we need to make it work with what's really here. So if I said y equals 3 times step 1, x is the step number, that would equal 3, but we've got 5. So I guess I'd need to add 2 more. And I'll add that to my equation. So this looks like our equation. Let's test it to make sure it keeps working with the next steps. So y equals 3 times step 2 plus 2. 3 times 2 would be 6, plus 2 would be 8. Yes, that's how many we have in step 2. How about step 3? Y equals 3 times step 3 plus 2. 3 times 3 is 9, plus 2 is 11. Yes, that's how many in step 3. This looks like a good equation. So y equals 3x plus 2. And to calculate the number in step 43, we can just put 43 in for x. So y equals 3 times step 43 plus 2. 3 times 43, 3 times 40 is 120, plus 3 times 3 is 9, so it's 129, plus 2, 131 people fitting around that 43 tables if they're all in a line. And I guess the thing that I've noticed about this is The most efficient way to use a trapezoid table is to not have them touching at all, right? Because if you've got a single table, you could fit 5 around them. So if you had a limited number of tables, or maybe you were renting the tables and you had to pay per table, if you had the space to fit them, you should have them all separate, I guess, rather than a big long line like this. Because when you have a big long line, almost every table only seats 3, because all the middle ones seat 3, and you've only got 2 on each end that seat 4. All right, well, how did you do on this one? Did you get 17 for step number 5? Did you come up with this equation? Let me know. Thanks, everybody.